The purpose of this lesson is to review some basic geometry concepts that you will need to know to work your trig problems. We'll start with some basic definitions. As you remember from geometry, we can draw a line through 2 points, and that line extends infinitely to the left and right of those 2 points. We call it line AB. If we only want to talk about the part of the line between A and B, then we call it line segment AB. And if we want to begin as an endpoint with point A and extend the line infinitely to the right through point B, then it's called ray AB. An angle is formed by rotating a ray around its endpoint. Here I have point A. Because it's the endpoint of the ray that I'm going to rotate, it's called the vertex of the angle. I take this ray, and since this is the original position of the ray, it's called the initial side of the angle. I'm going to rotate this ray in a counterclockwise direction, and this arc with the arrow shows the direction I rotated. Where I stop the rotation of the ray is called the terminal side of the angle. The direction that I rotate the ray determines whether the angle is a positive angle or a negative angle. If I rotate the ray in a counterclockwise direction, here's my initial side, I rotated it this way, here's my terminal side, then the angle is a positive angle. And if I rotate the ray in a clockwise direction, notice here's my initial side, I rotated the ray in a clockwise direction, here's my terminal side where the ray stopped its rotation, then the angle is called a negative angle. From geometry, we remember that we measure angles in degrees, and when we use the degree measure, we assign 360 degrees to a complete rotation of a ray. Based on the number of degrees in an angle, we classify the angles. An acute angle is an angle that measures between 0 degrees and 90 degrees. And here is an example. For an angle that measures exactly 90 degrees, you may remember that we call it a right angle. And when we have an angle of 90 degrees between these 2 rays, then one ray is perpendicular to the other ray, and this square tells us that these 2 rays are perpendicular to each other, that they form a 90-degree angle. If an angle measures between 90 degrees and 180 degrees, we call it an obtuse angle, and here's an example of an obtuse angle. Another special angle is the straight angle. It measures exactly 180 degrees, and our initial side would be at the positive x-axis, and if we rotate it 180 degrees, notice halfway, half of 360 degrees, then our terminal side would be on the negative x-axis if we had a coordinate system. when we measure angles in degrees, we also have a measurement for parts of a degree. Those measurements are minutes and seconds. In trig, it's important for us to be able to convert minutes and seconds of a degree to a decimal part of a degree. And to do that, we have to know the following facts. One degree is equal to 60 minutes, and this is the symbol that we use for a minute, and these are the words that represent those symbols. 60 minutes equals 1 degree. Of course, what that means is that 1 minute is 1/60th of a degree. 2 minutes would be 2/60ths of a degree. 5 minutes would be 5/60ths of a degree. Our minutes are made up of seconds. We use the inch symbol for the second symbol. You're probably familiar with the inch symbol. 60 seconds equals 1 minute. And there it is in words. Well, what that means is that 1 second equals 1/60th of a minute, and it also equals 1/3600th of a degree, because there's 60 seconds in a minute, there's 60 minutes in a degree, so the number of seconds in a degree would be 60 times 60, which is 3,600. Now let's look at some more definitions. You may remember from geometry that if the sum of the measures of two angles is 90 degrees, the angles are complementary. And if the sum of the measures of two angles is 180 degrees, the angles are supplementary. When we talk about an angle in standard position, that means that its vertex is at the origin and its initial side is along the positive x-axis. Now, notice my x-axis and my y-axis. Here's my initial side with the endpoint, the vertex, at the origin. I rotate it in a positive direction, which is counterclockwise, and there is my terminal side. Here's an example of a negative angle in standard position. Here's my initial side at the positive x-axis. Notice this time that I rotated it in a clockwise direction, and there is the terminal side. Another concept that we need to understand is the concept of quadrantal angles. Angles in standard position having their terminal sides along the x-axis or y-axis, such as angles with measures 90 degrees, 180 degrees, 270 degrees, and so on, are called quadrantal angles. Now, we've already seen examples of a 90 degree angle and of a 180 degree angle, but here's an example of a 0 degree angle. That might be relatively new. Notice that I have my initial side. There was no rotation of my ray, so my terminal side is right on top of my initial side. Look at my 360 degree angle. I have my initial side. I rotated it in a positive direction, a counterclockwise direction, all the way around. My terminal side is right on top of my initial side, so the measure of this angle is 360 degrees. Notice the only difference in a 0-degree angle and a 360-degree angle is the amount of rotation. For an angle that's 270 degrees, here's my initial side as if it were along the positive x-axis. If I rotate it 90 degrees for 180, and 90 more degrees, that's what a 270-degree angle would look like, and it would have its terminal side on the negative y-axis. The last definition I'd like to discuss before we work some problems is the definition of coterminal angles. Let's look at that. Angles that have the same initial side and the same terminal side are called coterminal. I have a 30-degree angle here in standard position. Notice its initial side is along the positive x-axis and its terminal side is in this first quadrant of the xy coordinate axis. Now, for this second angle, its initial side is along the positive x-axis, but I'm going to change the rotation. I'm going to take the ray and I'm going to rotate it all the way around. All the way around would be 360 degrees, plus 30 more degrees would make the measure of this angle 360 plus 30, or 390 degrees. A 390-degree angle and a 30-degree angle are coterminal because they both have the same initial side, they both have the same terminal side, only the amount of rotation has changed. Now for this third one, here's my initial side along the positive x-axis. This time I'm going to rotate my ray in a clockwise direction, so my angle will be a negative angle. And what I need to do is to figure out how many degrees I rotated my ray. Let's see, well, I know that all the way around is 360. I know that this part of it is 30 degrees, so if I say 360 subtract 30, I get 330 degrees. So the measure of this angle would be a negative 330 degrees. And please note, all three of these angles have the same initial side, the same terminal side. The only difference is the rotation of the original ray. Well, let's look at some problems. This one says find the measure of each angle. Well, notice what we have here. We have an angle, and we're told that it is 3z degrees, and it is right next to another angle, and we're told that the measure of this angle is 9z plus 6 degrees. Now, look what we know. See this box right here? What does that square mean between those rays? It means that these rays form a 90-degree angle. So that means that the 3z plus the 9z plus 6 equals 90 degrees. So we will set up the equation. Let's combine like terms. 3z plus 9z is 12z. Let's solve for z by subtracting 6 from both sides. we get 12z equals 84, and next let's divide both sides by 12. And we get that z is equal to 7. Now it says find the measure of each angle. So one angle would be 3 times 7, which is 21 degrees. The other angle would be 9 times 7 plus 6. 9 times 7 is 63, plus 6 would give us 69 degrees. And for a check, the 21 degrees plus the 69 degrees should give us 90 degrees, and it does. The second problem says find the measure of each angle if two supplementary angles measure 8x and 10x degrees. Now, what does it mean if two angles are supplementary? It means their sum is 180 degrees. So we take 8x and add it to 10x because we know it equals 180 degrees because the two angles are supplementary. Next, we'll combine like terms. 8x plus 10x is 18x. Then we'll divide by 18. So x equals 10. It asks us to find the measure of the two angles. So one angle, 8x, would be 8 times 10, or 80 degrees. And the other angle, 10x, would be 10 times 10, or 100 degrees. And sure enough, 80 and 100 are supplementary angles. Sometimes in trig we have to add two angles together or subtract two angles. So let's look at how we perform those operations. On problem number 3, we are to add 65 degrees 48 minutes to 53 degrees 29 minutes. We add degrees to degrees and minutes to minutes. When we add 8 plus 9, we get 17. 1 plus 4 is 5, plus 2 is 7. 5 plus 3, we get 8. 6 plus 5, we get 11. Now look at that angle. What we got was 118 degrees 77 minutes. We don't leave it like that. Any time that our minutes are 60 or greater, then we know that 1 degree equals 60 minutes. So we'll think 77 minutes equals 60 minutes plus 17 minutes, and the 60 minutes we will write as 1 degree. So 77 minutes is 1 degree plus 17 minutes. So for our 77 minutes, we will take the degree and add it to 118 degrees, which gives us 119 degrees, and then the 17 minutes is the part of the degree. On problem number 4, we are subtracting. We have 90 degrees, subtract 56 degrees, 42 minutes. Once again, we have to subtract minutes from minutes, so we'll rewrite the 90 degrees as 89 degrees, 60 minutes. 60 minutes is 1 degree. 1 degree plus 89 degrees is 90 degrees. We'll subtract the 56 degrees, 42 minutes. When we subtract the 2 from 10, we'll get 8. 4 from 5, we get 1, so we've got 18 minutes. 6 from 9 is 3. 5 from 8 is 3. So when we subtract those angles, we get 33 degrees, 18 minutes. Sometimes in trig, we want to convert angles that are measured in degrees, minutes, and seconds to decimal degrees. So let's look at some of those calculations. On problem 5, it says convert each angle measure to decimal degrees. Round to the nearest thousandth of a degree. Well, we know that 36 minutes is part of a degree, and we know what part of a degree it is. So we will write this as the 34 plus, since there are 60 minutes in a degree, 36 minutes will represent 36 sixtieths of a degree, and we calculate that on our calculators. We enter 34 plus 36 divided by 60 equals, and when we calculate it, we get 34 and 6/10 degrees. Now I know it says round to the nearest thousandth, but we'll just round to the nearest tenth here. On problem number 6, for our 57 degrees, 52 minutes, and 43 seconds, that will be 57 plus the 52 minutes is 52 sixtieths of a degree. And remember what the relationship was in seconds and degrees? There were 3,600 seconds in a degree. So 43 seconds would be 43 3,600ths of a degree. So we will calculate that with our calculators. That would be 57 plus, enter 52 divided by 60 plus 43 divided by 3,600 equals, and when we round that to the nearest thousandth, that would be 57, then 879 thousandths of a degree. The next problem that will work will convert decimal degrees to degrees, minutes, and seconds. Okay, what we have here is an angle in decimal degrees. It measures 284 and 2,367 ten-thousandths degrees. Let's separate that. We have 284 degrees, and then we know that this part of the number represents a part of a degree. It's 2,367 ten-thousandths of a degree. And what we want to do is to figure out how many minutes and seconds that's equal to. So we'll write the 284 degrees, and to figure out how many minutes this is equal to, we will multiply 2,367 ten-thousandths times 60, because there are 60 minutes in a degree. Multiply that out with your calculator, and when you multiply 2,367 ten-thousandths times 60, you get 14 and 202 thousandths minutes. So what this means is that this angle measures 284 degrees plus 14 minutes plus the 202 thousandths is part of a minute, And now what we want to do is to figure out how many seconds 202 thousandths equals. And so to do that, we will take the 202 thousandths, and because there are 60 seconds in 1 minute, we will multiply it by the 60 seconds. When we multiply 202 thousandths times 60, we get 12 and 1200ths seconds. Now we will round this to the nearest second, so our answer is 284 degrees, 14 minutes, 12 seconds. So an angle in decimal degrees that measures 284 and 2,367 ten-thousandths degrees will equal 284 degrees, 14 minutes, and 12 seconds. Most of your scientific calculators and graphing calculators have buttons that you can push that will convert your angles that are measured in decimal degrees to minutes and seconds, or if your angles are measured in minutes and seconds, it will convert to decimal degrees. You will just need to look at the instruction manual that came with your calculator to determine how your calculator works those problems. Now I'd like for us to look at some problems involving coterminal angles. Problem 8 says to sketch the angle in standard position, find the measure of two other angles, one positive and one negative, that are coterminal with the given angle. Give the quadrant of the angle. Well, for this 260 degree angle, in standard position means that initial side is on the positive x-axis, and we just estimate where that is. Since it's positive, we know that we go counterclockwise. We know 90 degrees is that far. Over to the straight angle is 180 degrees. We know all the way down to the negative y-axis is 270 degrees. So we're going to estimate that 260 is about right there. Now, when it says give the quadrant of the angle, that means what quadrant is the terminal side in. And I'm sure you remember from college algebra that this is quadrant 3. So it's a quadrant 3 angle. Now, it asks us to find two coterminal angles. Let's go ahead and find the positive one first. The one that I'm going to choose to find is, I'm going to rotate this initial side all the way around, and then 260 more degrees. So this angle would be 360 degrees for one rotation plus 260 degrees. Let's see, we get 0, we get 12, we get 6. So one positive angle that is coterminal with 260 would be 620. Now let's get a negative angle here. Remember, coterminal means same initial side, same terminal side. So for my negative angle, I'm going to rotate my initial side in a clockwise direction, and so I know the angle will be negative, but I need to figure out how many degrees I rotated. Now we know that all the way around is 360. We know that from here to here is 260. So to figure out how many degrees are left, we'll say 360 subtract 260, and we get 100 degrees. So the negative angle that I have sketched here would be negative 100 degrees. Let's look at another problem like this. Problem 9 says sketch the angle in standard position, and just like problem 8, we're supposed to find two other angles that are coterminal with the given angle. Well, for negative 192 degrees, first of all, in standard position, we start with the initial side on the positive x-axis. Because it's negative, we rotate in a clockwise direction. We want to go 192 degrees. Well, of course, we know that's 90 degrees. On up to the negative x would be 180. So we'll go just a little bit past 180. We'll just have to estimate on that. And there's my terminal side. Now, because my terminal side is in the second quadrant, we label this as a second quadrant angle. Now, let's find two other coterminal angles. First, I'll find a positive angle. Initial side, my positive angle would rotate in that counterclockwise direction and would have that same terminal side. I just need to figure out how many degrees this is. Well, if I went 192 degrees that way, and what I can do is to subtract 192 degrees from 360 degrees to determine the measure of this angle. Let's see, 2 from 10 would be 8, 9 from 15 would be 6, 1 from 2 would be 1. So this angle would be 168 degrees, and it would be coterminal with this negative 192 degree angle. Now, we're supposed to find a negative angle that's coterminal with 192. Well, here's what we're going to do. We will start with this initial side, and we know since it's negative that we will have to move in a clockwise direction. So we will go all the way around, which would be 360 plus another 192 around. So what we've got here is negative 360 because we went all the way around in a clockwise direction, and then another negative 192. When we add those, we get 2, we get 15, we get 5. So a negative coterminal angle with negative 192 degrees would be negative 552 degrees. We'd have same initial side, same terminal side. You're going to find in trig that the coterminal angle concept is very important. So we're going to work some more problems dealing with coterminal angles. Problem 10 says find the angle of smallest positive measure coterminal with the following angles. Well, first let's make sure we've got this negative 95 degree angle sketched. In standard position, initial side on the positive x-axis, negative tells us to go in a clockwise direction. We know 90 degrees takes us to the negative y-axis, so we'll go just a little bit past that, and we'll just sort of estimate on that. It doesn't ask us, but that would be a third quadrant angle because its terminal side is in the third quadrant. Now, if we want to find the smallest positive angle that's coterminal with this, go ahead and label it. Then the smallest positive angle that would be coterminal would be the angle with an initial side on the positive x-axis rotated in a counterclockwise direction. And so what we need to do is figure out how many degrees we rotated, and the way that we will do that is that we will take 360 degrees and we will subtract from that 95 degrees. We know that this rotation took up 95 degrees. We want to see how many degrees are left. When we take 5 from 10, we get 5. 9 from 15, we get 6. And 0 from 2 gives us 2. So the angle of smallest positive measure coterminal with negative 95 degrees is 265 degrees. Now let's look at number 11. 200 degrees in standard position. Initial side, rotate in a counterclockwise direction, 200 degrees, 90 plus 90 more, 180. We'll go just a little past the 180. Once again, we have a third quadrant angle. Let's label it. Now, if we want to find a positive angle that is coterminal with 200, what we will do is we will start with initial side positive x. We will rotate once for 360 degrees, and then we will rotate continuing in a counterclockwise direction 200 more degrees. So that angle would measure 360 plus the 200, or 560 degrees. Let's look at one more. 450 degrees, and we want to find the smallest positive coterminal angle with 450 degrees. Well, when we sketch that, initial side on positive x, for 450 degrees, that's larger than 360 degrees, isn't it? So we know we're going to have to rotate all the way around once would be 360, and then we need to figure out how much further we need to rotate that initial side. To do that, we will subtract 360 degrees from 450 degrees. When we subtract, we get 0. 6 from 15 gives us 9. So what we found is that for this 450 degree angle, we'll rotate 360 degrees and then 90 more degrees. And that would be a quadrantal angle because its terminal side is on the positive y-axis. Remember, quadrantal angles have their terminal sides on either the positive or negative x-axis or the positive or negative y-axis. Now, what is the smallest positive angle that is coterminal with 450? Well, actually, we found it right here, didn't we? By subtracting 360 degrees from 450 degrees. That smallest positive angle would be 90 degrees. Well, I want us to think about the problems that we've worked dealing with coterminal angles. Every time that we've had to find coterminal angles, what we've ended up doing is either adding or subtracting 360 degrees to or from the original angle, haven't we? Well, think about that as we look at these next two problems. The directions say, give an expression that generates all angles coterminal with the given angles. Let n represent an integer, and I'm sure you remember from your algebra that the set of integers would be all the negative numbers, -3, -2, -1, 0, 1, 2, on to infinity. Usually we say the whole numbers 0 and the negative whole numbers. For this angle that's 60 degrees, there's the initial side on the positive x-axis, there's the terminal side, and of course that's a quadrant 1 angle, and we have rotated it, the initial side, in a counterclockwise direction, 60 degrees. Now I think it's probably pretty obvious by now, if we wanted a positive angle coterminal with 60, we could add 360 degrees to it. If we wanted another positive angle, we would go around once, we would go around twice, and then rotate 60 degrees, which means that what we would do is take 360 and add to it 2 times 360. And if we wanted another one, we could rotate that initial side once, twice, 3 times, and then 60 degrees, which would be 60 degrees plus 3 times 360 degrees, and we could keep on, and I think you can probably see what the pattern is here. One way to find coterminal angles is to add what we call multiples of 360 to our original angle. This would be 1 times 360, 2 times 360, 3 times 360. Well, what if in this case we're looking for negative coterminal angles? Well, we know that one angle is this angle, and we know to get the number of degrees that we rotated the initial side in a clockwise direction, we have been saying 360 minus 60 gives us 300, so this angle is negative 300 degrees, isn't it? But I want you to look at something. Do you see that if we had taken 60 and subtracted 360 degrees from that we would have gotten the negative 300 degrees? And if we take 60 and subtract 2 times 360, let's just work that out. That would be 60 minus 2 times 360 is 720. 60 subtract 720 would be negative 660. Now, let's figure out where negative 660 would be. Do you see that for negative 660 that I would go in a negative direction, that would be clockwise, 360 degrees, and then I would go 300, and that negative 660 would also be coterminal with 60 degrees. Do you see the pattern here? To get angles that are coterminal with 60 degrees, we are adding or subtracting multiples of 360. Here we subtracted 1 times 360. Here we subtracted 2 times 360. To say that, notice how it says, give an expression that generates all angles coterminal with the given angles. So that expression would be 60 degrees plus 360 degrees times n, where our n is the set of integers. And so this would represent 1 times 360, 2 times 360, 3 times 360. This would be negative 1 times 360, negative 2 times 360, and so on and so forth. Therefore, for this 150-degree angle, how would we write the expression that would generate all angles coterminal with this given angle? It would be 150 degrees plus 360 degrees times n, where n is an integer. This completes this part of the geometry review. Please rewind the tape before you return it. Thank you.